Welcome back. This is the fourth video covering our June 2022 Algebra 2 Regents High School examination. In this video, we are going to cover part 2. We are doing problems 25 through 32. All right, some of you who are just interested in part 2 may be joining us for the first time. Others have watched the previous 3 videos, numbers 1 through 8, 9 through 16, and 17 through 24. All right, if you haven't already, hit the like button because you know you're going to like it. You already know you're going to like it. Or at least follow me so when I put new videos up, you'll be notified. I do Algebra 2 Regents. I have pre-calculus, which I run more like a general calculus. And then I actually have videos for my AP Calculus AB course. And I am going to start doing test reviews, like I do for Algebra 2, for calculus soon. So be on the lookout for that. Okay, let's get started. So to start, let's read the directions for part 2. There are 8 questions in this part. Each question or each correct answer will receive 2 credits. Clearly indicate the necessary steps, including appropriate formulas, substitutions, diagrams, graphs, charts, etc. Utilize the information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale. For all questions in this part, a correct numerical answer with no work shown will receive only 1 credit. All answers should be written in pen except for graphs and drawings, which should be done in pencil. Every year there is some kid that uses pencil over the whole test. That's the proctor's fault for not catching it. Well, I mean, it's the student's fault too. But this needs to be done in pen. And unlike part 1, you can get partial credit here. Okay? So if you come across a question where you can only figure it out using the calculator on a graph or something, do it, write down the correct answer, and receive 1 of the 2 points. Okay? For part 1 or multiple choice, it's either 2 points or nothing. Wow, look at that. Anyways, let's begin. Number 25 asks, does the question x squared minus 4x plus 13 have, or equals 0, have imaginary solutions? Justify your answer. Okay, justify means show math work. Explain means to actually write a sentence or 2 or a little note. Okay, so imaginary solutions. This is not factorable. The only way I know how to find actual solutions or roots or x-intercepts for something that's not factorable would be using the quadratic formula. But before you go crazy, okay, we're not going to use the whole quadratic formula. AC all over 2A. Okay, these will give me my answers. So how would I know if this response, if these answers are imaginary or not? Imaginary answers have negative values underneath the radical. If you remember from your work earlier in the year, imaginary numbers come from having a negative number underneath the square root. So the only thing I really need to do is determine if this value right here, I thought I hit red. Okay, if b squared minus 4ac, is it less than 0? Is it negative? I don't have to do anything else. I don't even need the square root. Okay, that, ladies and gentlemen, is called the discriminant. Okay, my a is 1, my b is negative 4, and my c is 13. So I will take my b value, square it, that gives me 16, minus 4 times a, which is 1, times 13, which would give me 52. And if I subtract those, I get a negative 36. Okay, I realize that my discriminant, b squared minus 4ac, is negative. I haven't answered the question yet. Does it have imaginary solutions? Yes. Make sure you answer the question. Okay, yes. Justification. My discriminant is negative. My math work is my justification. If you feel a little antsy and you want to say yes, there are imaginary solutions. Go ahead and write that too. Yes, imaginary solutions. How come? That's an O with an N. That is not an M. Okay. How come? Because that's negative. Easy. Number 26. The initial push of a child on a swing causes the swing to travel a total of 6 feet. Each successive swing travels 80% of the distance of the previous swing. Determine the total distance to the nearest hundredth of a foot a child travels in the first 5 swings. A couple of things to point out. Number one, anytime I use a percent in a calculator, I'm going to make that into a decimal, 0.80. Okay, because we do not have a percent key in the calculator. So when I do the math, I got to turn it into a decimal, and anytime I need that rate or percentage, I need to use the number 0.80 in the calculator. The next thing that should jump out is when you're rounding to the hundredth of a foot. That is 2 decimal places. Okay, hundredth. It goes tenths and hundredths. Okay, so how do I do this? There is a formula on the reference sheet, okay? Bam. You can see this is the June 2022 exam. Okay, if I go to the end, okay, on this reference sheet, all right, if I want to, where are we? Add up a geometric series. How do I know it's a geometric series? Okay, well, it's geometric because, where are you? There you are. I'm going to put this. That's a sequence. I want the series. I'm going to add it all up. Okay, this is just saying R can't be 1, because if you have a 1 in for this R right here, then you get a 0 on the bottom. So I don't need that right now. And let's put that, paste. Okay, how do I know this is a geometric series? Okay, a geometric series, okay, if I really wanted to, if I didn't know how to do this, okay, the first swing, 5 swings, 1, 2, 3, 4, 5. The first swing is 6 feet. If I wanted to find 80% of 6 feet, what I could do, okay, is just take 6, and I know students who would do this because they wouldn't know to look in the back, 6, and multiply that times your 80%. So the next swing, 80% of 6, okay, is 4.8. So the next swing would go 4.8 feet. Now I got to take 80% of that. So everything is being multiplied by 0.8 or 0.80. So now I'd go back to the calculator and I'd say 4.8 times, so I'm taking my answer, 4.8, and multiplying it times 0.8 or 80 again. And the next swing would be 3.84 feet. So I could do this 3.84 because there's only 5, and I would add them all up. Okay? Whatever was here and here, add them all up. I could do that. But I'm going to use this. What does this tell me? A1, okay, that's my very first number on my list. That's going to be my 6. Okay? So that's going to appear in 2 spots. So what's my R? My rate is my 0.80. That's going to go in 2 spots. And what's my N? My N is my number of swings. Okay, you notice I have 1, 2, 3, 4, 5 values that I'm adding together. Okay, so I'm literally going to put in the calculator. And if you started to do this and just continued it and added it up, that's fine. See what I get here. Why am I doing this geometric series equation? What if there was 48 swings? You can do that 48 times in the calculator? That's insanity. Okay? So my A1 is 6 minus my A1, which is 6, times my R, which is 0.8 or 0.80, raised to my N, which is 5, all over 1 minus my rate, which is 0.80. Okay, 1 minus my rate in the bottom. I just have to put that in the calculator once. Okay, I have to put that in the calculator literally once. Okay, so I'm going to do alpha y equals enter. I always do that for fractions. And type it in just as I have it here. Let me see, will it make a difference? I like using the bigger screen, but for right now, let's use the smaller one. 6 minus 6 times 0.80 raised to the 5th power all over 1 minus 0.80. 20.1696. Okay, so when I write my answer down, I say 20.1696. It's a good thing that you guys underlined this right here and knew that you needed to round this to the hundredths. So you should end up with 20.17. Oh, no, get out of here. And that's what I would get if I added up all these numbers in the calculator anyways. Okay, I spent more time explaining the difference than I did doing the math. Number 27. Solve algebraically for n. N. I have 3 denominators. They all have n's in them. And I have 2 over n squared plus 3 over n equals 4 over n squared. Well, if I can, I would like to make all my denominators the same so I can cross them out and get rid of all my fractions. There are plenty of other ways to do it, but that's the way I'm going to do it. I actually have an n squared here and an n squared here. So I just need to make this into n squared. Yep, this into n squared. So I'm going to take n and multiply it times n. What I do to the bottom of a fraction, I have to do to the top to make it the same. So my numerator, my top, will be 3n. The bottom, n times n, is now n squared. If all of my bottoms are the same, I can wipe them out, and what I have left is my new equation. 2 plus 3n equals 4. Let's literally do 2 things. Subtract the 2 first. Now let's divide by 3. So your n is equal to 2/3. Oh, I love it when they're simple. Love it, love it, love it when they're simple. Factoring problems. Factoring never goes away. You need it in pre-calculus, you need it in calculus, any math, unless it's like some sort of theory of mathematics, in which case I'm sure you're probably going to use it. Factoring never goes away. I have 4 terms here. That means I have to factor by grouping at some point. But the rule of thumb, well, I say states, but the rule of thumb that I always state to my students is I always take out a common factor first if I can. I notice that every term here has an x, but I'm going to take out, I'll do it over here, a negative x. How come? I like when my first term is positive. It's always easier. I don't want to leave the negative 2 there, so I'm going to take the negative out with an x, which means I am going to flip all the signs of all these terms because I'm taking a negative out of all of them. And I'm going to take an x as well. So I have 2x cubed minus, so that'll go from a plus to a minus. Notice that went from a minus to a plus, the positive 2. Negative x squared, because I took an x out, negative 18x, I took an x out, and that'll turn to a plus, plus 9. I took the x out. Okay, I took out a GCF. That's exactly what I need to do first. Next, I'm going to factor by grouping. So I'm going to take these 2 and factor a GCF out. And I'm going to take these 2 and factor a GCF out. And hopefully what's left in the parentheses will match. So I can take out an x squared. That will leave me a 2x minus 1. I want to take something out so that I end up with 2x minus 1. And in order to do that, I've got to divide both of them by a negative 9. Not just a 9, a negative 9. If I divided by a positive 9, this would have been a negative 2x, and this would have been a positive 1. It would not have matched. So I need to take the negative out with it. And oh, don't forget, this bad boy has to come along for the ride. We can't just leave him out. All right, so factoring by grouping tells me, oh, get to use the highlighters. These two get written in their own parenthesis, and then I write one more parenthesis that would have 2x minus 1. I don't have to write it twice. Okay, so I have x squared minus 9 in one parenthesis. And then I have 2x minus 1 in another one. And oh, by the way, he still comes along for the ride. Now, most of you might be like, wow, that was kind of complicated, Visca. I'm glad you're here to help us. Not so fast, my friend. Because this right here is known as a DOPS, a difference of perfect squares. That can actually factor into an x plus 3 and an x minus 3. That is just this one right here. This is a lot of work for a 2-point problem. I would expect this to be a 4-point problem. And then my negative x comes for the ride. Now I am completely done. And that is completely factored. This is factored, okay, the step before it, but it's not completely factored. And they're asking us to factor it completely. Number 29. Okay, checking for dependence or independence. Okay, we have a probability or a statistics problem here. All right, and there's always multiple ways to do this, but I think I'm gonna show you the way that I like to do this, given this situation. Okay, 29 states the relative frequency table shows the proportion of a population who have a given eye color and the proportion of that same population who wear glasses. Okay, so there we go. Blue eyes, brown eyes, and green eyes who wear glasses and who do not wear glasses. Okay, so given the data, are the events of having blue eyes, I'm going to highlight this because then we can see what's underneath it. Having blue eyes, which would be here, okay, and wearing glasses, will that turn too dark? Oh, there we go. Are they independent? Justify your answer. So first of all, let's think about independent versus dependent. Dependent, does something depend on something else? Would I wear glasses just because I had blue eyes? Do you think wearing glasses depends on your eye color? It does not. When everything is all said and done, it should be independent. Okay, at least in real life. So let's see if, at least, according to this table, the same thing happens. Now, if they're independent, their probabilities will be the same. If I have blue eyes, just in general, if the probability of me having blue eyes is the same as me of having the probability of blue eyes given that I wear glasses, if those two probabilities are the same, then it is independent. And there's that fancy word again, justify your work. So you got to show some math work. Let me state that one more time. If the probability that I have blue eyes is the same as a probability that I had blue eyes, sorry, this stylus makes my B's look funny. Given I wear glasses, I'm going to WG for wear glasses. If those are the same, those probabilities, then it's independent. Okay, so what's the probability that I wear blue eyes? I don't care if I have glasses or not. Let's do this one right here. Blue eyes, 0.14 have blue eyes. I should do this. 0.14 have blue eyes that wear glasses, and 0.26 have blue eyes and don't wear glasses. So the probability of just having blue eyes, whether I wear glasses or not, I'm going to add these two up, and I should get 0.40. Okay, so 0.40. Let's see if this is the same thing. Okay, so here we go. How do I figure out, okay, given that vertical bar that I have written in between blue and WG? Okay, this right here means given. So how can I determine that probability? Okay, given wearing glasses, I don't care about this anymore. Given that I only wear glasses, if I add these up, all three of these, that's 0.35. So out of the 0.35, how many have blue eyes? 0.14 out of that 0.35. 0.14 out of that 0.35. So I got to figure out what that probability is. Okay, so I'm going to use my handy dandy calculator. Let's get this bigger again. Okay, that would be nice if it actually responded. Yeah. Okay, well, we'll leave it like that. Come on. Third time's a charm. Wow. So I'm going to take 0.14 and divide it by 0.35. 0.4. It's also 0.4. That is also 0.40. They're the same. So let's answer the question. Are the events of having blue eyes and wearing glasses independent? Yes. They're independent. How come? Where's the justification? Right here. They're the same. They're equal. So you have a 40% chance of having blue eyes, and you have a 40% chance of having blue eyes and wearing glasses. So it doesn't matter whether you have blue eyes or not if you're going to wear glasses, because they're both 40%. Number 30. For x not equal to 0 and y not equal to 0, the cube root of 81x to the 15th y to the 9th, okay, equals 3a x to the 5th y to the 3rd. What is the value of this a? Ooh, interesting. They want us to find the value of this bad boy right there. All right, so the first thing I'm going to do is I'm going to try to get rid of that radical slightly. Maybe not completely, but slightly. What do I mean? Okay, I know that the left side here is the cubed root of 81 times the cubed root of x to the 15 times the cubed root of y to the 9. Okay, and I know I got to divide a 3 and a 15 here, and that gives me x to the 5th. I know I got to divide my 3 into my 9 here, and I get y cubed. Okay, and I still have this. I'm not going to do anything here because that doesn't come out to be a nice even number yet. That equals this side. 3a x to the 5th y cubed. What you should realize by now is these are the same on both sides. So if I wanted to, I could just get rid of them. What do you mean get rid of them? Let's divide both sides by x to the 5th y cubed. X to the 5th y cubed. Gone, 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 gone. So now I have a situation where I have the cubed root of 81 equals 3 to the power of a. If I can get the bases the same, then I can set up the exponents to be the same. Okay, so 81 is actually 3 to the power of 4 equals 3 to the a. But keep in mind, if this 81 is under a cubed root, then guess what? This 81 also needs to be under a cubed root. So I got to do this. The cubed root of 81 is the same thing as a cubed root of 3 to the 4th, because 3 to the 4th is 81. All right. So now I'm just going to rewrite the side, top, down, bottom, out. Okay, the bottom of my fraction was the one that popped out. That was my cube. The top of the fraction is the one that just came down. So that can be rewritten as x to the 4/3 equals x to the 4/3. It's 3 to the 4/3 equals 3. So hey, guess what? If this 3 has a 4/3 exponent and they're equal, this 3 needs to have a 4/3 exponent. So my A needs to be 4/3. Look at us go. We did some math. Very good. Oh boy. Oh boy. Graph y equals 2 cosine of 1/2 x plus 5 on the interval from 0 to 2 pi using the axis below. Look, you could easily put this in the calculator. Okay, you can easily put this in the calculator. The thing is, you would have to change it to radians, or, look it, if you don't know this, okay, if you don't know this, 2 pi is the same as 360 degrees. If I were to convert the radians to degrees, and then I could leave my calculators in degrees, and I could graph that, and my x-axis would be from 0 to 360. Okay? You can graph it right in the calculator, but, because I know my equations, and I want to review that with you right now, we're not going to use a calculator. Okay? So what I'm going to do is, let's see if we can move this slightly up higher. Oh, no, I got you right there. All right. So first of all, I am going to label my x-axis. From 0 to, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So every 2 here. I'm going to go out 2 more, 2 more, and 2 more. 0, and it'll end at 2 pi. Okay. This one is 1 pi. This is pi over 2. And this is 3 pi over 2. All right? That's my x-axis, the interval right here. Because we're not going in the calculator right now. We're just going to go from 0 to 2 pi. Now, cosine. Cosine, when you graph it, looks like the cup. Okay? 2 is my amplitude. That tells me how high from the midline I go, how high from the middle, and how low from the middle I go. What do you mean? 5 is my midline, so right around here should be the y value of 5. And I'm going to go up 2 to 7, and I'm going to go down 2 to the number 3. That's the low point will be at 3, and these points will be at 7. But the kick to the proverbial crotch here, kids, is this value right here, 1/2. That's the frequency. That's how much of my curve I'm going to see in 360 degrees. Only half of it. I'm only going to see this half. I'm not going to see the second half at all. How come? Tells me I'm only going to see half right here. So let's plot this, right? Let's actually number. We have 1, 2, 3, 4, 5, 6, 7. I want to write the even numbers too. Go ahead. Go right ahead. You have every right to do that. I'm just being lazy. Now, okay, I know that at the beginning, I'm going to start way up high here at 7. Okay, so I'm going to start way up high here at 7. Okay, I'm going to end at 360 degrees, or 2 pi, at the bottom here at 3. So 2 pi at 3. And in between, exactly in the middle, okay, here's where I start. Here's where I end. In the middle, I'm going to be right at 5. So the middle, 1 pi, I'll be right at 5, right there. All I've got to do is create a curve to connect them. And it's kind of got to start out like this, come down, curve there. That's this curve all dragged out. And I knew that without the calculator because the midline is where the middle of my curve is. The amplitude is how high up and how far down I go from that midline. And my frequency tells me how much of the curve I'm going to see. We are finally to number 32, the last question for today's video. A cup of coffee is left out on a countertop to cool. Love me some coffee. The table below represents the temperature. Can I stop here for a second? When you brew coffee at home, make sure you use Coffee Mate's Peppermint Mocha Creamer. It's like Christmas every morning. Is something I would say if Coffee Mate wanted to sponsor this video, but secretly I have an addiction to Peppermint Mocha Coffee Mate Creamer. Not International Delight Coffee Creamer. The Coffee Mate one is delectable. It's fantastic. Okay, I'm sorry. I got sidetracked. A cup of coffee is left out on a countertop to cool. The table below represents the temperature, F of T, in degrees Fahrenheit of the coffee after it is left out for T minutes. Okay? Based on these data, oh, that's weird. I like this data, but it's data plural, these data. Based on these data, write an exponential regression equation, F of T, to model the temperature of the coffee. Round all values to the nearest thousandths. This will be done completely in the calculator, and you don't have to show any work, you just have to write the equation. Some things to note that you better note, because even though we're doing it all in the calculator, there are ways they're going to fool you here. One, what type of equation do they want? If they ask for an exponential regression, give them an exponential. Don't give them a quadratic. Okay, don't give them a cubic regression. Give them an exponential, okay? Nearest thousandths. Thousandths is 1, 2, 3 decimal places. Oh, and by the way, given the equation F of T, I will tell you that in one moment. That will come back. Now, in the calculator, we don't have F of T and T. We have X's and Y's. Okay, these are going to be our X's. These are going to be our Y's. You will have to do this probably once on your exam, so make sure you know how to do this. All right? I'm going to bring this down here so we can see our table and which one's X and Y. So when you have your calculator, the first thing you're going to do is you're going to press the Stat button right here, Stat, and then notice it's already on Edit. So I'm just going to hit Enter, or I could press the number 1. You are going to enter your X values into L1, and your Y values, okay, are going to go into L2. So 0, 5, they go up by 5 until I hit 25, my X's. 10, 15, 20, boom, 25. There we go. All right. Now I got to enter the corresponding Y value for each X. Okay. I have 180, enter. I have 144, enter. 120. I think between 120 and 150 is drinkable, isn't it? I think 180 drinkable coffee is between then. Anyways, let's get off my coffee addiction right here. Okay, 120, 104, 93.3. Look at a decimal in there, and 86.2. The first thing I do is I just quickly glance to make sure I didn't miss anything, because it is real easy when you're typing in. Let me say that again. It is really, really easy when you're typing in, and I swear I put 15, but you're missing the 5 here, or you're missing the 1 here. It is just take a quick glance, boom. Make sure all these are 3 digits. It's real easy to forget a decimal. Okay, or this might look like 14 instead of 104. Just look it over. Okay, now that you have everything in, I'm going to go back to Stat. Now I want to calculate my regression. I want the calculator to do the work for me. I want the calculator to do the calculations. So I'm going to move to the right, and I'm not going to pick linear regression, quadratic, or cubic, whatever they ask for. In this case, it's exponential. That's the one I'm going to pick. So let me go down here. Exponential regression. You can select 0. You can press the 0 or go here and hit Enter. Yes, L1 is my X. L2 is my Y. I'm just going to go down here and hit calculate. Bam. And there's my regression. Now here we go. Let me put this out here because we're done with the calculator. I'm going to scroll down here. So we've got some room. So right now, according to my screen here, I have my y equals my a value, 169.00. Look, we need to go 3 decimal places. That 6 will stay a 6 because the number after it is 0. So 136. Okay, I multiply my a value times b. Yep, that green, you saw me hit it, guys. If I go 3 decimal places, that 1 will stay a 1 because the number after it is a 1 raised to the x. Why would I get 1 point taken off here? But write in an exponential regression with the equation f of t. They don't want us to use y. Visca, that's dirty. That's what they do. You need to follow directions. So instead of y, I better use f of t. Okay, equals 169.136 times 0.9710. Whatever variable is here is the one I need to use. I cannot put an x here. I need to make sure I put my t there. You need to have this right here written with your f of t and then your t. We are done. That is all of part 2. Let me make sure that's all of part 2. And guess what? I told you were going to like the video. Just like it. I mean, already? Gosh. Just like the video already. Give me a follow. You'll get notifications when I put this stuff up. It's really helpful for Algebra 2 Regents, pre-calculus, and calculus AB. And keep in mind, my pre-calculus course is really a general calculus. Okay, so that might differ slightly than your pre-calculus course. But if you're in calculus, maybe you want to follow pre-calculus, if that makes sense. Either way, look around. Give me a like, give me a follow, and I'll see you later.